Hi there, this is a VoLTE architecture tutorial. My name is Vikas and I am subject matter expert in the telecom industry. Here I am going to simplify VoLTE mystery for you. Are you finding 3GPP specs extremely complicated, clumsy and hard to understand? Yeah, it's complex. Well, not to worry at all. This is a right place for you. I am going to simplify and make it easy for you so that you are going to remember it forever. I assure you, you will feel much more comfortable with VoLTE architecture within next few minutes. Let's start our journey with VoLTE. Hi, along with explaining the VoLTE architecture, I am also going to provide you 2 bonus tips on VoLTE network in the end. You will not find these practical tips anywhere else since I have learned these things over the time during past few years. This video contains gist or summary of all my learnings. I believe in building concepts. Without solid foundation, you will trouble creating anything of a value. I am going to work on building your fundamentals in this particular video. This video will cover up high level notes in VoLTE and also covers deconstruction of telephony services along with integration of IMS functions. Let's quickly jump onto the fundamentals here. Let's discuss about high level VoLTE connectivity. What is VoLTE? As diagram suggests, it's all about carrying voice over LTE data network. Since IMS is a part of third generation partnership project also called as 3GPP, this makes IMS as a standard solution with predefined internetworking with underlying 3G and 4G services. Along with LTE network, operator can harness the true power of IMS, which stands for IP Multimedia Subsystem. IMS is a standalone system which resides out of the LTE network and connected to PDN gateway or P gateway through SGI service. Now we can see this whole IP network, which is LTE as an access, is being used for carrying the voice calls. Now let's discuss something about IMS. Now IMS, as it have been shown in the center in the orange color, you can clearly see like IMS is sitting out of a LTE network. It's a standalone network which is sitting in the middle. Now let me tell you something about the IMS. IMS is a very old concept and it was very popular in year 2003 to 2004, almost 12-13 years back. This used to be a failed concept. What happened at that point of time when IMS have came into the picture and it was introduced in 2003 year, operators have conceived this as a failed technology because it is too complex. Operators have seen it too expensive and too burdensome to be introduced and to maintain. Now with VoLTE launch, this again got popular. Now VoLTE requires IMS to be there and to be sitting on top of the core LTE network. This have made IMS popular again and it's in the demand nowadays again. Okay, now in coming slide we are going to discuss the VoLTE building blocks. I'm straight away jumping to the next slide. As we discussed earlier, it's all about voice over LTE and it's more or less exactly what it says on the tin. Rather than 2G or 3G connections which are actually used for voice calls, VoLTE offer voice calls over the IP to IP based 4G network. We tend to think 4G as mostly being about downloading, streaming and web browsing. Indeed, that's primarily what it's been used so far, but it can also be used to the next level of voice services with IMS. Now let's quickly see what are the benefits which users are going to get along with the VoLTE service. The first benefit which user is going to get is the superior call experience. The greatest advantage of VoLTE is that the voice quality is superior from 2G or 3G connections. Essentially, it's an HD voice call. It's a much richer experience overall for end users. Similarly, VoLTE also provides a faster call setup. VoLTE can connect call up to twice or thrice as fast as currently used in 2G or 3G network. A typical 2G 3G call takes 4 to 6 seconds for maturing, while VoLTE call requires only typically less than 1 second or 1 to 2 seconds for getting connected end to end. Other benefits of VoLTE for end user are better battery life. Anyone who uses 4G could also find their battery life increased with VoLTE. For a non-VoLTE call, handset need to switch from 4G to underlying 3G or 2G network to receive voice call. This is done using CSFB or circuit switch fallback technology. This frequent switching of mobile from 4G to 3G and vice versa consumes a lot of battery. In VoLTE call, user need not to go to 2G or 3G network to receive voice call. Now that saves battery for end user. Similarly, there is one more benefit which user is going to get. That one is the video calling. Just like OTT providers, WhatsApp, Facebook, Google Duo and Skype, VoLTE also gives you a video calling service. Now the benefit of this video calling service is it's available on the stop dialer from the main handset itself. You need not to download any third-party application from Google Play Store or maybe from the Apple Store. It's directly available on the handset itself. You put a SIM, it's a VoLTE enabled SIM. If it is a VoLTE enabled handset, you can straight away make a video call, just as simple as that. Okay, now as next step, we are also going to deconstruct the entire network which is going to be used for VoLTE, wherein like we are going to discuss about handset, the LT network, the IMS core and the voice PSTN in coming slide. On left hand side, we can see SIP enabled user equipment. This handset or smartphone needs to be VoLTE compliant, where SIM should support iSIM and SIP user agent for making voice calls over VoLTE. The second one is the LT network, which typically shows the A node base and the LT code network. We'll also discuss this one in a brief in coming slides. The third one is the IMS network, which is sitting on top of underlying LT network. The last one is the PSTN network, which is used for break-in and breakout of calls from IMS. We are going to discuss all these components in detail in the coming slides. Let's quickly jump to the VoLTE handset component, the first one. We'll start our journey with user handset. For VoLTE to work, the user handset must support two critical things. One is the SIM support, which is there on the left hand side, and then the VoLTE binary application in the handset, which is also called as user agent, which is on the right hand side. So let's start with the SIM piece. SIM plays a crucial role in the VoLTE support. SIM is known by the name of UICC, which stands for Universal Integrated Circuit. There are primarily three types of SIM cards. The first one is the typical SIM, which is used for 2G or 3G. This is a traditional SIM. It securely stores the international mobile subscriber identity, which is IMSI, and it also stores the related key used to identify and authenticate customers on a mobile telephony. The second type of SIM is USIM. The USIM was introduced with the launch of 3G and 4G services. This is a new age SIM card which came to us. The last one is the iSIM, which is used for VoLTE services. iSIM is also known as the IP Multimedia Services Identity Module. This is used by IMS or VoLTE subsystem for authentication and rest of the SIM functions. There are two types of entities which are stored on this iSIM. First one is the IMP. IMP stands for IP Multimedia Private Identity. IMP is a global identity allocated by home network. IMP contains the home operator domain information. The second one is the IMPU. IMPU stands for IP Multimedia Public Identity. IMPU acts like a telephone number which can either be a SIP URI or a TEL URI as defined in RFC 39664. Now let's see what is there on the right hand side. It's our SIP user agent which we are going to discuss. Unlike 2G or 3G or LT, where all the handsets are default supporting all available network, VoLTE requires a detailed handset testing and certification of every handset make and model. This testing is required as handset manufacturer and operator will be seeking to assure themselves as the underlying protocol features that are present and functioning correctly. The operator want to ensure that underlying IMS and protocol is functioning and performing as intended in order to deliver the expected quality of service. SIP user agent is typically a binary which resides inside the handset. The main function of this binary is to transmit and receive the SIP messages. It provides all the telephony functionality. It is acting as a client or a server for exchanging the SIP messages with the IMS core. Now that's all about handset. Now let's quickly jump to the next slide, wherein we are going to cover the high level building blocks of LTE network. Okay, now we have covered the first piece. Now let's quickly jump onto the second one. Okay, this is a LTE architecture slide. I assume you already know LTE architecture and will not spend too much time here. All yellow nodes are control plane and are responsible for user authentication. Control plane node includes eNode B, MME, HSS, OCS, PCRF. The green one are the user plane, which includes eNode B, S gateway and P gateway. The eNode B is a radio cell site of a LTE network and is used in both control and user plane. P gateway is also used for both user and control plane traffic. Now we have covered user handset and LTE core network. It's time to demystify IMS core network. VoLTE voice call traffic is originated by user handset and terminates on IMS network. LTE network is just used as a bridge, acting as an IP supporting carrier for this communication. Now we will jump onto the IMS core without wasting any further time. This is 3GPP IMS architecture. I'm going to simplify this in another few minutes and you will be able to understand every individual component shown in this complicated diagram. The VoLTE IMS architecture is covered under 3GPP 23.228. Similarly, you can also refer to a GSMA document GSMA FCM01 and GSMA IR92. These two documents are really good if you want to further study VoLTE and want to go in the depth. You can refer to GSMA documents. We'll start with the high level concept of LTE network and going to stitch it together with IMS. This is a typical LTE network which provides high speed internet access. Traffic flows all the way from mobile handset to eNode B to S gateway to P gateway to the internet cloud. Signaling is controlled by MME and P gateway with support of HSS and PCRF. You can see a user payload traffic flow along with arrow on the screen. LTE network is part of evolved packet system as shown in diagram here. Our IMS core integration begins here. IMS stands for IP Multimedia Subsystem. IMS core is directly connected to P gateway as shown on the screen. This is connected over SGI interface. For LTE network, IMS or SIP traffic is just another payload similar to the internet traffic. LTE P gateway doesn't decode or interfere with this traffic. LTE is used as a carrier for accessing IMS service which provides IP telephony or voice services over IP network. There could be multiple access type for IMS networks such as Wi-Fi or fixed broadband or DSL or something like this. From this slide onwards, I'll start breaking down the IMS cloud in various bits and pieces to make it more clear to understand. IMS core consists of broadly two types of network element. First is the SIP infrastructure and another type of nodes are media gateways. These are tightly coupled under IMS core network. Let's understand the SIP server in detail. Users are going to register with SIP server, which is a part of control plane and signaling. This SIP server will set up media part or payload of voice call with media gateway as shown in blue color, which is further connected to the PSTN network. SIP server is the anchoring point for session setup, session teardown and session control along with CDR generation. SIP server is consisting of various submodules covered in the upcoming slides. Media gateway. Now let's understand the media gateway, which is highlighted in green color. Media gateway is responsible for carrying actual voice traffic and handing it over to the other networks. These media gateways handle inter-networking of voice traffic between IMS and PSTN networks. Any call coming from the traditional 2G or 3G or fixed line network is using this media gateway as an entry point in IMS network. Media gateway is an interconnect point to circuit switch network and other IMS network. It also handles transcoding of the media plane. Broadly, it's the gateway between the LT and other PSTN networks. For the sake of easiness, I'm using only one box depicting LT network. This consists of MME, S gateway and P gateway. There can be multiple access networks for providing IMS service. This could be Wi-Fi, fixed broadband, DSL or LT network. As long as user handset support SIP device and has IP connectivity to reach IMS, we can offer IMS service to the user. IPCAN stands for IP Connectivity Access Network. This is equivalent to bearer of a IP connectivity established from user towards IMS or a service network. Now I am going to discuss the most critical element of IMS core network. We call it as CSCF. You can see it here in central SIP server. You can also see it here along with SIP proxy in the diagram. It stands for Call Session Control Function and act as a heart of IMS system. The CSCF performs all the signaling operation and manages SIP session and coordinates with other network entities for session control, service control and resource allocation. It consists of three different entities: Proxy CSCF, the Interrogating CSCF, which is also called as ICSCF, and the last one is the Serving CSCF, SCSCF. Let's start with first entity, PCSCF. PCSCF is also known as Proxy CSCF or Proxy Call Session Control Function. This SIP proxy is sitting in front of SIP server always. SIP proxy is the first point of entry to the IMS network. This proxy SIP server is usually located in the visited PLMN network, I mean to say the roaming network. This SIP proxy has several important functions such as validation of correctness of the SIP messages coming from the user. It also ensures the security. It also does the function of authentication and asserts the identity of the UE. In last, it also finds out the home SIP server IP and routes the traffic to same. I am adding up two things here. One is the interrogator and another is home subscriber server. Let's discuss the interrogator. ICSCF or Interrogator CSCF perform below critical functions. SIP proxy forward the request to the interrogator, which in turn finds out where SIP server to select. User may be served by various SIP servers, while only one SIP server serves the customer. While SIP proxy is usually located in the roaming or visited network, interrogator sits in the home network. So this is visited network, this is home network. All the main task of the interrogator is to select the correct SIP server or registrar which is going to serve user. All this communication between proxy, interrogator and SIP is always on SIP protocol between all these nodes. ICSCF queries the HSS using the diameter CX interface to retrieve the user location and then routes the SIP request to its assigned SCSCF during registration of a call. It is also used during the empty call routing. Now let's discuss the HSS, which is also known as Home Subscriber Server. The HSS is the database of all the subscribers and service data. HSS contains the subscription related information used by the control layer. HSS is the master user database that is used for registration authentication in both LT network as well as in VoLTE IMS network. This allows the user to access the packet core and circuit domain of the network initially via IMSI authentication. HSS communication is via diameter protocol. For super easy understanding, HSS is used as a profile or a database of a user where all information is saved. This HSS will decide whether you are allowed to use VoLTE or not. This will decide whether you are even allowed to use LT or 4G network or not. That's the role of HSS. It's a significant stuff after the LT launch. The Telephony App Server, also called as MMTEL or TAS. Till now we discussed IMS core, which is great for handling SIP, but this requires app server to provide various supplementary services. For example, voice call in mobile network requires Telephony App Server, also called as TAS. We need a similar app server for another multimedia services such as video, gaming, etc. Application server host and execute lot of services and interface with SCSCF using SIP. This allows third-party provider to provide an easy integration and deployment of their value-added services to the IMS infrastructure. IMS was never intended to be limited for voice users only. Rather, it was designed for multimedia services, and voice is only one part of same. IMS is not a service but a service facilitator network. It enables user to access various applications such as telephony service. App server handles the telephony part, while SIP server is still controlling the session such as initiation, maintain and tear down of session. The TAS provides the telephony brain to the app server. TAS is a telephony app server used for telephony service such as call waiting, call hold, pickup, forwarding, call transfer, call blocking services, malicious call identification, lawful interception, announcements, digit collection, conference call services, and so many of them. We can check various other app servers such as like video app server, conference bridge server, etc. It's an add-on to the IMS. Just like TAS, we can add on all these application servers onto the existing IMS network. App servers are not considered as part of core IMS service. In this slide, we have split media functions into two parts: control and payload function. The top one is the control function. The lower one is the user payload function. Media control is performing critical control plane function for VoLTE calls. Let's discuss this one in detail. User can make call to PSTN network or fixed line network where media control and gateway is supposed to speak to PSTN network over IZOOP or SS7 protocol. User can also make call to another IMS network. Media control handles the part of a call state that pertains to the connection control of the media channels. Media control communicates with the SIP server and selects the appropriate node depending upon the routing of a number for incoming calls from the legacy networks. Media control is also performing a protocol conversion between IZOOP and IM subsystem for call control protocols. It also controls the media gateway resources with H.248 interface. It does all the control function of a voice call. Now let's discuss media gateway. Media gateway is an element responsible for payload handling of a VoLTE call. Here is media gateway. It interacts with the control and terminates bearer channel from a switch circuit network and media streams from a packet network, example RTP streams in an IP network. It also interfaces the media plane of CS network by converting between the RTP and PCM. It can also perform media transcoding when the codecs do not match. Example, IMS might use AMR or PSTN might use G711. These two are different codecs. Other than media conversion, it also performs bearer control and payload processing using codec, echo canceller, and managing other onboard resources. Net, this is the guy who is going to ensure both the nodes, one side on LT speaks to the another side PSTN. Here I am going to further expand media control and media gateway into actual node functions. IMS gateway, which communicates with other IMS network. 3GPP names of these nodes are IBCF and TR gateway. IBCF is a control plane entity and TR gateway is user plane entity. Similarly, PSTN gateway is the node which communicates with the PSTN network. 3GPP names of these nodes are MGCF and IM Media Gateway. MGCF is a control plane entity and IM Media Gateway is a user plane entity. ATCF stands for Access Transfer Control Function. AT Gateway stands for Access Transfer Gateway. As name suggests, these both access nodes resides in the servicing IMS network, that is visited network in the roaming case. They interact with LT network for media control and payload handling. This is the node who is going to speak to the LT network down the line. ATCF also handles the access side media control for handling voice calls with LTP gateway. ATCF also plays vital role in enabling SRVCC session transfer mechanism. The AT gateway is a media function that is used to anchor the media with LTP gateway. Net, its job is to interface with LT and hand over or receive the calls from the underlying 4G or LTE network. Now I am showing all three media entities in one screen. While MGCF and IM Media Gateway is designed to communicate to PSTN network, such as traditional voice network running on SS7 or iZoop, IBCF and TR Gateway is designed to inter-network with other IMS network running on SIP. This is a prime reason for breaking them into various network elements. PCRF. PCRF is used for both IMS and LT network. The main purpose of PCRF is to apply policy to PDN or IPCAN session. The PCRF provides priority of bearer used for making VoLTE calls and SIP signaling. The QoS provided by PCRF provides highest priority to VoLTE voice traffic. This prioritization helps voice calls to pass through even in case of radio congestion. PCRF also anchors communication between PCSCF and P gateway over GM protocol reference point. Now we are going to discuss MRF. MRF stands for Media Resource Function. MRF is both gateway and control function. It deals with call conferencing and things associated with RTP mixing. It also used for announcement and media related functionalities. MRF provides media plane processing independent of application type such as transcoding, multi-party conferencing, network announcements, tones, etc. Now let's discuss our last component, which is BGCF. BGCF stands for Breakout Gateway Control Function. Serving CSCF needs to make decision where to route SIP message, that is to PSTN or to other SIP network. It really need to decide where to route the call. BGCF simplify this routing job by making this decision about routing the call to the destination network. This is similar to our B number table of the MSCs. BGCF is responsible for determining the next hop for routing the SIP messages. For PSTN terminations, the BGCF determines the network in which CS domain breakout is to occur and selects the appropriate MGCF. For termination in peer IMS network, the BGCF selects the appropriate IBCF to handle the interconnect to peer IMS domain. So this is the guy who is going to take the routing decisions and who is going to route the calls on the respective IBCF and the MGCFs. Okay, so now we have covered almost everything out there in IMS. Let's see the complete VoLTE IMS picture. The IMS architecture involves a clear separation of 3 layers. Okay, now this green one is the transport layer, the blue one is the application and services layer, and now this red one is the session and control layer. The entire IMS is divided into these 3 layers. Now let's see the big picture. We have covered all the way from the user handset to the LT network to the IMS core to the voice PSTN. This is the complete network diagram for VoLTE or IMS services. Okay, now let's see what happens when there is a congestion in the radio. Have you ever thought what will happen to voice call during these congestions? As a general principle, data internet can wait for some time, but voice call cannot. Voice has to be real time. LTQoS provides a flexibility to prioritize the bearer or connection during the radio congestion. Since voice cannot be compromised and cannot afford delays, VoLTE is always provided the highest priority over the internet traffic. With help of this QCI, I prioritize the VoLTE over the generic internet. I'm using typically 2 QCIs. The first one is the QCI 5, which is used for IMS signaling. The another one is QCI 1, which is typically used for the voice IMS call. Rest of the QCIs, which belongs from 6 to 9, belongs to internet. They are always low priority as compared to IMS. They never provide guaranteed bitrate. Instead, they work on the best effort basis. Please refer to my another video on VoLTE IMS registration for detailed understanding of this along with other concepts and call flows of VoLTE registration, IMS APN establishment and default EPS bearer setup. I'm going to cover all these concepts in detail in coming videos. Okay, here is another bonus tip for you. Okay, now let's understand what all it takes to deploy a VoLTE in an existing 4G network. Let's see what all is required on the P gateway or S gateway or on an existing LT network. On P gateway, the first piece is to enable the default and dedicated bearers. The default and dedicated bearer concept is required when we are making multiple bearers for having a SIP signaling, for making additional voice calls on the existing LT network. The second piece is the IMS APN IP pool. Obviously, we are going to give a new IP pool for IMS APN. I'm also going to connect my P gateway to IMS. The last one is I also need to disable the online charging of the SIP signaling and the voice calls for data piece. I'm going to charge the voice calls as voice, but not going to charge them for the payload carried over data in terms of MB. I'm going to do the charging on per minute basis, but not on per MB basis. Similarly, let's see what all changes are required in MME. The first critical thing which we are going to do is SRVCC. I'm going to cover SRVCC in coming videos. The second one is again the IMS APN has to be created. The third one is the paging policy for VoLTE calls. Every incoming call to a VoLTE customer requires paging. We need to define a high priority paging for VoLTE. And then the last one is the QCI definition in MMEs. This is something which we recently discussed in our previous slide. Now let's see what is required in the voice core or MSS network in order to support VoLTE. The first one is the SRVCC, which is required to hand over a call in case the customer goes out of coverage area. I'm going to cover this particular element in the coming videos. The second one is again the reachability between the CS core network and the IMS. The third one is the configuration for break-in and breakout calls from IMS or vice versa. The last one is the codec negotiation, which is going to occur between MSS and IMS. Again, another bonus tip. Let's assume there is an operator who don't have iSIM. Do existing 3G or LTE customer using USIM need to go for SIM swap for availing quality services? How do I launch VoLTE if I'm having only USIM type of SIMs available in the network? Do I need to go for SIM swap of all the entire base with iSIM? Well, no. There is a workaround available. USIM can be used to avail VoLTE services also. USIM with help of the binary, with help of the SIP user agent, can derive IMPU and IMPI for authentication. If you want to download this PPT or video, please visit my website. It's telecomtutorial.info. Hope this video presentation is useful for you. Please feel free to like, dislike, comment and share. Please subscribe to my YouTube channel for more technical videos.